This is for section 9.2 and 9.3, where we are multiplying polynomials. 9.3 is just some examples that are special products, so you'll notice some rules that we can remember to help us do it faster, but you don't have to necessarily memorize those because the methods that we will use in 9.2 will work for those special products as well. There is no new vocabulary, so we'll just start with an example. If we are multiplying a monomial and a polynomial, remember that means one by itself and one that has multiple monomials together, we're essentially just going to treat it like we're distributing the monomial to each part of the polynomial. So 2x cubed has to go to each one. So 2x cubed times x cubed plus 2x cubed times 3x squared plus 2x cubed times negative 2x plus 2x cubed times 5. Alright, and here this goes back to all our rules for exponents. So 2x cubed times x cubed becomes 2x to the 6th, remember we're adding exponents, plus 2x cubed and 3x squared, 2 times 3 is 6, x cubed times x squared is x to the 5th, 2x cubed times negative 2x becomes minus 4, x cubed and x makes x to the 4th, and then 2x cubed times 5 is just plus 10x cubed. And that would be our final answer for that one. For this example, I'm going to show you two different ways to do it. So for multiplying two polynomials together, the one thing that gets tricky is that we have to remember to get every possible combination. So to do that, you can either use a table or use the FOIL method. So first let's use a table. So I have two terms here and two here, so I'm going to need 2 by 2 in my table. Okay, so I have the x, the 1x, and then positive 1. And then up here I have another 1x and a negative 2. Okay, so I'm just going to multiply each. So x times x will give me x squared. X times negative 2x, x times negative 2 becomes negative 2x. 1 times x is a positive 1x. And 1 times negative 2 is negative 2. So then I'm just going to write everything out and combine like terms. So I end up with x squared minus 2x plus x minus 2, and negative 2x and positive 1x can be combined, so I get x squared minus x, negative 2 plus 1 is negative 1, minus 2. And that would be my final product. The second method you can use for multiplying polynomials, this actually only works for multiplying two binomials, but it's called FOIL. So it's a way to help you remember to get each combination, and it stands for first, outer, inner, last. So 2x times 4x would be the first combination, 2x times 1 would be the outer combination, 3 times 4x is the inner combination, and 3 times 1 is the last combination. So if we try that with the same one, x times x gives us x squared. That's first. Outer, x times negative 2 gives us minus 2x. Inner would be the positive 1 times the positive x, so that's plus x. And then last is 1 times negative 2, and that would be minus 2. So then again, just like the last one, we combine like terms, and we end up with x squared minus x minus 2. So FOIL will absolutely work, but just be aware that it only works when we have two binomials, so two polynomials that have exactly two terms in them. Here's another example, only this time we have a trinomial and a binomial. So foiling won't work, but we can use our table. So if I make my table so that it's 3 by 2, okay, I can write everything out. So I have b squared here, 6b, positive 6b, and negative 7. And then up here I have 3b and negative 4. So then, again, I'm just going to multiply every combination. B squared times 3b is going to become 3b cubed. Remember, 3 times 1 is 3. B squared times b to the first, add exponents. B squared times 4 becomes 4b squared. 3b times 6b becomes 18b squared. B times b is b squared. 6b times 4 is 24b. And negative 7 times 3b is negative 21b. And negative 7 times 4 is minus 28. So now I'm going to write all of that out and then combine terms. So 3b cubed plus 4b squared plus 18b squared Alright, there it is a little smaller. And now we just have to combine like terms. So 3b cubed will stay. 4b squared and 18b squared will give us 22b squared. 24b minus 21b is positive 3b, and then minus 28. And that would be our final answer. And I have two examples of special products. So again, all the same rules will apply. It's just that if you were to do other examples that look just like this, you would start to notice a pattern. So x plus 3 cubed, let's think about what that means. That just means x plus 3 times x plus 3, because it's the whole thing squared. So now, since I have binomial and a binomial, I can choose. I can either do a table or I can FOIL. So if I FOIL, I get x squared plus 3x plus 3x plus 9, and then that becomes x squared plus 6x plus 9. Alright, and another special product, if you have two binomials where one is positive and one is negative, and other than that they're exactly the same, something kind of cool happens. So let's just set up a box this time and see what happens. So again, I have 2 here and 2 here. So I need a 2 by 2, 2x and positive 1, and 2x and negative 1. 2x times 2x is 4x squared. 2x times negative 1 is minus 2x. 1 times 2x is positive 2x. And 1 times negative 1 is negative 1. Now, when I write it all out, you might see what's going to happen. 4x squared minus 2x plus 2x minus 1. Well, you end up with negative 2x and positive 2x, which are actually just going to cancel each other out. Because negative 2x plus 2x is just 0. So all I end up with is 4x squared minus 1. And anytime you have two binomials that are exactly the same, other than one is positive, one is negative, the same thing will happen. So to show you one more example of that, if we do x minus 3, x plus 3, watch what happens. So again, I get x squared plus 3x minus 3x minus 9. Those cancel, and I'm just left with x squared minus 9. So it's just the first two terms multiplied times the last two terms multiplied, because the middle is always going to cancel. So if you see this and you remember that pattern, you're welcome to skip actually multiplying it out. But if you don't remember that and it doesn't make sense, just stick to either foiling or writing out your box. And that's it for this section.